on?
Morning.
Let's check this out.
When we discover the power that's in our hands, we find the motivation to make and the confidence to build. Because when we build, we become stronger than the tools we carry.
An engine starter motor is a powerful electric motor used for cranking an engine. The starter motor has a pinion, which meshes with the teeth on the flywheel of the engine and turns the crankshaft. The model shown here is a pre-engaged type starter motor used in modern vehicles. It uses an electric motor to provide torque to the crankshaft. The power for this motor can be drawn from the battery. A simplified circuit of power supply is shown here. The power from the battery is supplied to a solenoid. An ignition switch is installed between the battery and the solenoid to turn the power on and off. The solenoid is an electromagnet which requires small current to get energized. As the ignition switch is turned on, the solenoid gets energized. A moving core, known as a plunger, slides along the coil, which connects two copper terminals of a contactor switch. This completes the circuit from the battery to the motor and causes the rotor to spin. When the solenoid is de-energized, the core returns back and disconnects the motor from the battery. We may wonder why the solenoid and the contactor are used instead of directly connecting the battery to the motor and reducing the complexity. The reason behind not using this circuit is the high current demand of the motor. The motor is considerably powerful and demands heavy current for operation. To handle this current, the ignition switch needs to be unusually large. It also requires very thick wires running from the battery to the switch and then to the motor, which is technically inconvenient. This is why a solenoid is used, which demands lower current for being energized. The solenoid has another crucial function. It helps to slide the pinion and engage it with a flywheel before the motor starts to spin. As the pinion slides towards the flywheel, it slightly rotates on its axis, as shown here. This rotation is achieved by using a helical spline. This rotation helps meshing the pinion with the flywheel more conveniently. As the pinion and flywheel is properly meshed, the contactor switch gets closed, and the motor spins. As we can observe that the pinion is considerably small compared to the flywheel, the gear ratio of the flywheel and pinion is generally from 15:1 to 20:1. The high torque obtained from this gear reduction is still insufficient to crank the engine. So, a planetary gear set is introduced to increase the torque further. Planetary gears are incredibly useful for large gear reductions with less weight and limited space. It consists of a sun gear, a ring gear, a carrier, and a set of planet gears. In starters, the ring gear is fixed, the sun gear is the input, and the planet carrier is the output. For the setup shown here, the gear ratio is 7:1. The combined gear reduction results in enough torque to spin the engine. As the engine is started, the pinion needs to be disengaged from the flywheel to prevent backdrive of the motor, which might damage it due to the excessive speed. This is done by releasing the ignition switch, which de-energizes the solenoid, and the pinion returns back. But if the operator fails to release the ignition switch as soon as the engine is started, the flywheel will drive the pinion too fast and damage the motor. To prevent this, a one-way clutch is used. The one-way clutch has a set of rollers installed between the outer and inner races. When the outer race is rotated by the motor, the rollers get trapped and transfer power to the pinion. As soon as the engine is started and drives the pinion at a high speed, the rollers get released and power transfer is stopped.
Now, if I had seen videos like that since the beginning, I would have aced like every task.
That help you understand how a starter works?
Yeah,
Of course
a lot
it does.
more with the sun gear and
The Cantina chicken quesadilla isn't just for late night.
I love
Yeah.
that.
They got planetary gear system, just like transmissions do, right?
Yeah.
For gear reduction, gives you the
Yeah.
torque to crank the engine.
It has a
Yeah, and
perfect
now,
slow roasted
now
chicken
it
and
like,
melted cheese
it,
rate.
every, like so many things clicked because of that video.
Yeah. Yeah, we need to do some more of these.
That's chicken on the inside, cheese everywhere else. Introducing the new Cantina Chicken Quesadilla, only at Taco Bell.
When the ignition key is turned, it causes a small current of electricity to flow into the solenoid coil. The solenoid is usually made of two coils, known as the pull-in coil and the hold-in coil. The end of the holding coil connects to the casing of the starter motor, so the current returns to the battery via the frame of the car. The pull-in coil is connected to the main output terminal. Both coils are energized to create a strong magnetic field. This pulls the piston back, and as the contactor plate connects across the main terminals, both ends of the pull-in coil will become the same voltage. There will be no voltage difference across this coil at that point in time, so the coil will turn off, because there's no current flowing through it. It takes far less energy to hold the piston in position, so the hold-in coil continues to run. As the piston moves back, it's going to pull on the lever. This pivots and transfers the motion to the drive sleeve, pushing it forwards. As it moves forwards, it slightly rotates the pinion, allowing it to lock the rollers in the clutch and slide the pinion into the flywheel. As the contactor plate connects across the terminals and turns the pull-in coil off, a very large current will now flow through the contactor plate, through the thick wire and into the brushes. From here, it flows to the commutator plates and through the coil. Then back to another commutator plate and through another brush, which is grounded to the frame of the car. So the current returns to the battery. The coil produces an electromagnetic field which interacts with the permanent magnet or field winding in the stator. This interaction causes the rotor or armature to rotate very fast and with a high torque. The rotor transfers this through the shaft, through the clutch and into the pinion gear, which turns the flywheel. As the flywheel starts the combustion process, the engine will eventually begin to rotate the flywheel faster than the starter motor. This unlocks the overrunning clutch, so the pinion gear spins freely. When the key is released, it cuts the power to the solenoid coil, which releases the piston. The spring pushes the lever back, removing the pinion gear from the flywheel. The current is cut to the starter motor. The combustion engine continues to run by itself, and the alternator recharges the battery. We have also covered how the car battery works in detail previously. I'll leave a link for you in the video description down below. Check out these videos to continue learning about automotive engineering, and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, Instagram, TikTok, LinkedIn, and the
I like that.
Yeah, that helps, right? Okay. So, maybe what I'll do is try to find something like that before we start each one of them, so you kind of have a little bit of an understanding about what we're talking about when we go through it, right?
Yeah, that
So-
would be great, yeah.
So we're gonna go through the cranking system, which is obviously your starter motor, everything that interacts with it, from the push button or the ignition, if it uses a key, to what we just saw there. How you doing today? You all right? You sure? Okay, you with us? Yeah? All right. We're one short, but he's just gonna have to catch up. All right, should be on 598. This is our cranking system, which is pretty much what you just saw there. So hopefully it'll be a little easier to understand. We'll go through it. Okay. Parts, operation, cranking circuit, computer controlled starting. Most cars have computer controlled starting now, which means you don't really have control of the engine starting. When you turn the key or push the button, the computer takes over from there. Okay? You don't have to, if you have a car with a push button start, you don't have to hold the button down to crank the engine. You just have to push it and release it. The computer does the rest. Same if it has a key. You just turn it one time to start and let go of it, and the engine will crank until it starts. Because the computer takes over, you're no longer holding it to make it crank, okay? That's computer controlled starting. A starter converts electrical power and mechanical power, different types of starter motors. As you can see, most of them now have planetary gear sets in for gear reduction, increases the torque that the starter is able to deliver to the flywheel, cranks the engine easier and faster.
Well, when you started with the key,
What's that?
you started with the key, you just send the remote send the signal to the computer.
Yeah, as soon as you turn the key, it sends a crank signal to the computer, and the computer actually engages to start it through relay, stuff like that, so, yeah. And what it'll do is it'll crank the engine until it starts, and if it doesn't start, it'll shut it off in about, I don't know, 6 or 7 seconds. It won't crank it very long. And then, for some reason, the engine doesn't start, you have to try it again, but it won't just keep cranking the engine. It will stop it after a few seconds. I'm not sure exactly what it is, though. Starter drive solenoids. Okay, your cranking circuit involves your starter motor, the battery, starter, solenoid, or relay, starter drive, and ignition switch. Ignition switch does not operate the starter unless the automatic transmission is in neutral or park, or if it's manual transmission, you have to have the clutch pushed in. Okay, you can have a neutral safety switch or a clutch safety switch, depending on whether it's an automatic or manual transmission. Okay. If you look in the picture on 599, you will see in between the ignition switch and the actual starter motor, there's going to be a transmission neutral safety switch for an automatic or a clutch switch for a manual. Okay? If for some reason that switch is not working, the car will not crank. That interrupts that start wire. Okay? Everybody should know what a starter looks like, right? Bolted to the engine. A lot of times on cars now, in order to unbolt the torque converter, like if you're pulling the engine and transmission out, you have to take the starter off to get to the bolts on the torque converter. Then you got to rotate the engine by hand to get to each one of the bolts. But okay, so this is kind of like what we saw in the video. Your ignition switch at the top there. When you turn the key, it closes that circuit, sends power to the solenoid. Ignition cylinder is often a separate part of the electrical ignition switch. It operates directly, use the link between the two components. So what they're getting at here is your ignition lock cylinder, the mechanical part that the key actually turns, is separate from the electrical part of the ignition switch. They're not the same thing. Your ignition lock cylinder is kind of like a lock in a door. Okay? It's just a mechanical part that rotates this shaft here and turns the ignition switch electrical part.
Oh.
The electrical is actually what sends the power to the starter solenoid, okay? So these are separate pieces. The ignition switch and the lock cylinder for the key are not the same thing. Sometimes people want an ignition switch for a car and they'll, or a lock cylinder, and they'll say, I need an ignition switch. This isn't the ignition switch. That's just the lock cylinder where the key goes, okay?
So back in the day, that's why, like, because I don't think you can do it now, but back in the day, you used to be able to start with the flathead.
Yeah.
So you can't do that nowadays, can you? I don't know if you can.
No. It's just like using tools to pick a lock on a door. You could do the same thing with a car back on the older cars.
Yeah.
If you could get that lock cylinder to release like the key does, you could start the car.
Oh, okay.
Yeah. Or if you broke that lock cylinder and just forced it to rotate, you could start the car.
Oh.
That's how people would steal cars sometimes, or sometimes they just pull that lock cylinder
Pop
out
it off, yeah.
and then use a pair of pliers
Yeah.
to start it, or a pair of needle nose pliers.
Yeah,
That's how people used to steal cars back in the day.
yeah.
One of the ways. All right, to prevent the engine from cranking, electrical switch is installed to open the circuit between the ignition switch and the starter solenoid. Again, it's one of these two, okay? Automatic transmission, manual transmission, they do the same thing. This just requires the clutch to be pushed in. This just requires the transmission to be in park or neutral. Engine will not crank on an automatic if it is not in park or neutral, and it will not crank if the clutch is not pushed in on a manual transmission. The reason they want the clutch pushed in is because that way it doesn't matter where the shifter is. If it happens to not be in neutral, if you have it in gear, when you push the clutch in, it disconnects the engine from the transmission so the car doesn't just take off when you go to start it. Okay? You all right over there? You not feeling good today? What's wrong?
I'm good though.
You sure?
Yeah.
All right. All right, what are the parts in typical cranking circuit?
Starter motor, battery, starter solenoid or relay, starter drive, ignition switch.
All right, good. Starter motor, battery, starter solenoid, relay. A lot of systems have starter motor, or starter solenoid and relay. Starter solenoid on the starter. It can have a relay in the electrical center here. All right. Ignition switch, start position on the push to start button is just an input signal to the PCM, okay? Which we talked about a minute ago. When you push the button, if it's a push button start, or same thing if it's a key start and it's computer controlled, all that does is send an input signal to the PCM telling it you want to crank the engine. It takes over from there. Remote start, everybody's familiar with remote start. A lot of cars have remote start where you can just push the button on the key fob and your car will start. If you don't get in the car within probably 10 minutes, it shuts itself off, okay? So it's not like somebody can steal the car. The doors have to be locked and the alarm set before the remote start function will work anyway. So it's not like somebody could make off with the car, okay? And again, after about 10 minutes, the engine shuts off, so. Button on your key fob, it's gonna look like this if it has remote start. It's gonna have like a little arrow showing, you know, just like the rotation of the key. So if your car has remote start, you're gonna have something that looks like that on your key fob, okay? If it doesn't, the car doesn't have it.
Some cars have it too, but they don't have that.
What's that?
Some cars have it, but they don't have that circle. You usually gotta press the lock button, because if you might have unlock
It doesn't have, I've never seen one that doesn't have that button that has remote start. Maybe, I don't know, maybe they do. But I know you have to hit the lock button twice and set the alarm before the remote start will work. Also, interesting little bit of information. If the check engine light's on, the remote start is disabled. Won't work.
Really?
Yep. I found that out on my car. One time that I was, used the remote start on it, wouldn't start. I couldn't figure out why, and I thought, because the check engine light was on at the time. Needed a catalytic converter, I just hadn't replaced it yet. And thought, I wonder if that's why. So took a scan tool, cleared the code, and then it started working again. So the check engine light's on, the remote start won't work, at least on some cars. On mine it doesn't.
Wow.
So if you ever get a car, with a complaint of, the remote start doesn't work, just make sure that that's not the reason. So you're not chasing your tail, like, why doesn't this work? It's leading you down the wrong road when the problem was checking your lights on, and that needed to be corrected.
What if it throws another equipment in your way?
What's that?
What if an airbag light comes on, the brake light comes on, and another light comes on?
Just mainly the,
As far as I know, just to check into like, we'll disable the remote start. I don't know if the others will or not, but I know for sure that one will.
All right, starter motor uses the principles of electromagnetic energy to convert energy from battery to mechanical power to crank the engine. Series motor develops maximum torque at initial start, develops less as engine speed increases. This is just talking about different types of starter motors and the way they're wired. Permanent magnet starters use gear reduction to multiply starter torque. Compound ones use field coils are connected to the armature in series. I don't have to worry too much about that. Series wound electric motor, 2 brushes, one hot, one ground. Again, just electromagnetic principles here. Field windings and starter motor. They're going to go through a little bit of stuff inside the starter, like repair, rebuild, something like that. Don't have to worry about that. If you have a bad starter on a car, as you know by now, you're just going to get a new starter. And most of them come with solenoids, so it's all one piece. You just unbolt the old, put the new one on. So you don't have to take it apart, figure out what's wrong with it, rebuild it. We used to have to do that, but you don't have to do that anymore. Series wound armature, parallel, that's a little bit of both there. How the starter motor works, we went through. It has the field coils, armature, and then the housing. The brushes supply the proper current to the armature. 4-pole motor must have 4 brushes riding on the commutator. Permanent magnet field, so there you go, there's your starter motor. Drive in, it bolts to the engine. We don't have to worry too much about those. It's just the inside with the armature that actually rotates through from that magnetic field. There you go, there's kind of a, not a cutaway, but kind of a transparent picture of what it would look like inside. Kind of the same thing we saw in the videos. So on these cars would have start-stop systems on them, you know, where the engine will shut off when you come to stop and it'll start when you let your foot off the brake. Some of those have what they call permanently engaged starters, where this drive is permanently engaged, the flywheel. That's one of the ways they start so fast. The starter doesn't actually have to engage, it's permanently engaged. It just has to activate the starter motor and the engine starts. And they use a couple of they typically use more than one crankshaft position sensor too, so the computer knows exactly where the crankshaft is. So the engine doesn't even have to rotate one time before it starts. So,
Arthur, I'm sorry to cut you off. Are you referring to the permanent magnet motor that you're talking about right now?
let me see, I'm not sure what you're referring to.
On page 602, when you said that it stays in place?
Oh, no.
Oh, okay.
Somewhere in here we'll probably get to permanently engaged starters. Yeah. On the section that says start-stop systems.
Oh, okay. Oh, you're up there. Oh, okay.
Yeah. No, I was just bringing that up.
Oh, okay.
All right. We've seen the gear reduction in the video. The purpose of that is obviously to provide torque multiplication to crank the engine, produces necessary cranking power with reduced starter amperage requirements. Use a planetary gear set, which we saw. Video is very helpful for those things, I believe. There's another shot of it there. You can see the gear reduction planetary gear set there. Okay, the starter drive includes the small pinion gears that mesh with the rotating larger gear on the flywheel or flex plate for starting. Normally the ratio is 15 to 20 to 1, like they mentioned in the video. So all that means is it takes 15 to 20 rotations of the starter to make the engine rotate one time. Okay? Drive operation, we saw that as well, has a one-way clutch that allows the starter to rotate the engine, but then turns freely if the engine speed is greater than the starter motor. The major wear occurs in the overland clutch section of the starter drive unit. The entire starter will have to be replaced as a unit. Again, you don't have to buy separate pieces and rebuild starters anymore, but used to have to do that. We saw the overrunning clutch and how that works. Typical ring gear starter pinion ratio, we saw that 15 to 1 to 20 to 1, somewhere in there. The solenoid, that's your electromagnetic switch. That is the one that actually moves the arm, pushes the starter pinion gear into the flywheel. They have internal windings, which we talked about before, and we saw in the video as well, the hold in and the pull in winding. Armature. There's going to be a little thing on the quiz that has a picture of some starter pieces, and it's going to ask you which one's the armature. Looks like that, okay? All right, on the start-stop system, the purpose of those is obvious. It should be, right? Just to save fuel while the engine's idling. So what it does, it shuts the engine off sometimes after the car comes to a stop. Conditions for start-stop to occur: the accelerator is not depressed, vehicle speed has to be low or 0. Battery state of charge has to be above a certain threshold, hood has to be closed. Hopefully you're driving with the hood closed. Components for the start-stop system, they will have a auxiliary battery, smaller battery, typically in the trunk. Sensors, should switch, AC control. So what that does is if you turn the air conditioner on, the car will just start.
Huh, what? Say that again, what?
If you have a car with a start-stop system and you come to a stop and the engine shuts off, if you decide you want to turn the air conditioner on before you take off, the engine will just start as soon as you turn the air conditioner on. All right. And you know, most cars that do have start-stop system, they have a button to shut it off if you don't want to have that. Some people get annoyed by that. They don't want the engine shutting off when they come to a stop. So most cars have a button where you could actually shut that off so it doesn't work, okay? All right. Can a start-stop system be turned off? Yeah, most of the time. Button for it on there. Main advantages: improved fuel economy and emissions.
If you go down to the dealership, they love that system. I don't want the start-stop system.
Well, all they got to do is push the button and shut it off. You can't take it off the car.
They want to get to stop, but they don't want to have it at all.
Well, they shouldn't have bought the car then, because you can't remove it. It's not possible.
You take it off.
No. All you gotta do is push the button on the dash and it shuts it off. And it doesn't work anymore.
Every time you turn on the car, you have to hit that button.
That, I don't know. Some systems reset every ignition cycle. I don't know about that. It probably does. So every time you start the car, you'd have to push the button to start the system off. Most likely.
Question.
Yeah.
You know how you can basically, when you go to the dealership and purchase a car, you can kind of customize, right? Can you have it to where, since so many vehicles are coming with that start-stop button, can you tell the dealership, send it back to the factory and bring me one that doesn't have that? Can you request it, like picking off of what he was saying? Because like you can customize things at the dealership, you can, you know,
You can't customize anything really at the dealership. It has to be built that way. It would be a special ordered vehicle, where
Yeah.
you went in and said, I want this car, this color, this option,
Yeah.
whatever.
Uh-huh.
But if that's standard equipment on that car, they cannot remove it. If it's optional, they can. That's the difference between standard equipment and optional equipment. If the car comes standard with that, meaning every one of them has it, it cannot be removed. Okay, they won't build it without it.
I mean, the car has it, it's just like essential now.
It depends on the car. Some it's an option, some it's standard equipment, and that's the difference. If it's optional, you could find a car on the lot somewhere or order one that didn't have it, if you didn't want it. But I don't know why you would want to do that, because again, all you gotta do is push the button that shuts it off.
Cause I like old school, like writing checks, you know? There's nothing like it.
Right? Okay. You already did this, right? All right. Nobody gets special paper today. Printer has regular paper on it today.
Okay, how's it going?
Yeah.
You should have already been done, but, I don't know, were you?
No,
No, you didn't get that one done? But you had the sheet already. Anybody still working on it? Okay. All right.
You ready, right? Okay.
When the starting system component uses a small amount of current to throw a large amount of current. A.
Starter solenoid or the relay, that is correct.
Most remote start systems will shut off the engine after 10 minutes unless reset by the remote power.
10 minutes, okay.
Number 3, a starter motor rotates about blank times faster than the engine.
A. 18.
Okay, what's the gear reduction numbers?
15 to 1.
10,
Oh.
10 to 20 to 1?
Yeah.
So it's gonna rotate, what, 18 times faster probably?
Yeah.
Okay. A is the answer, okay. Starter motor can produce up to 8 horsepower, yeah.
Number 5 is not C.
B?
C.
Both.
I got B, page 605.
Okay. This is, let me see.
Where it says failure mode in 605. Says the starter drive is generally a dependable unit and does not require replacement unless defective or worn. The major wear occurs in the overrunning clutch section of the starter drive unit. A worn starter drive can cause the starter motor to operate and then stop cranking the engine further, creating a whining noise. The whine indicates that the starter motor is operating and that the starter drive is not rotating the engine flywheel. If that's not right, please let me know.
No, that is right.
Okay.
A starter solenoid cannot cause a whine. Starter solenoid is just an electromagnet. Can't cause a whine. Starter drive can.
What is B?
B, yes.
Turns.
I'm not sure if I got this one right. I looked on page 600, and then I just found something on page 606, so I'm not sure about this one, but on a vehicle with computer controlled starting, some key operated ignition systems and most push button to start systems use the PCM to push the engine. The ignition switch start position or the push to start button is used as a relay signal to the
Input,
PCM.
no? It's an input telling the car what to do?
Did you say so?
Is it an input?
I wasn't sure. I found relay on page 600, but then, where it says series, no, where did I see relay? Oh, where it says principles, starter motor operation, but then on page 606, at the start-stop system, I didn't see anything, so I'm really not sure.
Okay. Remember we talked about this, anything that has computer controlled starting, as soon as you push that button or turn the key, it sends an input signal to the PCM telling it that you want to crank the engine, and then it takes over from there, grounds the starter relay, whatever it has to do to crank the engine, okay? This is really all you needed to see. There's only one of these that would be a signal, and that would be the input signal.
See, initially I was going with output, and then I read that on page 600, and I switched it to relay, and then I just didn't know.
A button or a switch can never be an output, always an input,
No.
okay? Overrunning clutch on 7.
I'll put C.
C?
Yeah.
C is not the right answer.
Is
B.
it D?
It's B.
It is not B either.
It said protects, but then
It does, yeah, you're
On
right.
page 605, yeah.
It's D.
It is
Overrunning
D.
clutch prevents the starter from spinning too rapidly. So what happens is once the engine starts, if it's still engaged, the starter's gonna spin really fast because the engine's running now, right? So that overrunning clutch protects it from damage.
what's that?
On a vehicle equipped with the stop-start system, the engine stops when the vehicle is stopped at a traffic light. The system increases fuel economy.
That should be pretty obvious. If the engine's not running, it's not using any fuel.
Yep.
Okay.
Number 9.
Mm-hmm.
The neutral safety switch is located.
C.
I got C on page
Between the
598.
ignition switch and the starter solenoid.
What page?
598.
First page of the chapter.
It's also on 606.
Run.
What's that?
Turn the AC on.
Is it not?
Yeah.
What the heck? Why is it 83 in here? It said on 76. That doesn't make any sense. Why it was set at 83. Okay, that should help.
9 is C.
Where is the starter, or the neutral safety switch located? Between the ignition switch and the starter solenoid, right?
Yep.
Okay. What safety device do they use on manual transmissions?
Clutch safety switch.
Clutch safety switch. Neutral safety switch is only on automatic, but they do the same thing, right?
6 is input.
52D. Question number 1 is the same one we just saw. Permanent magnets are commonly used for what part of the starter? Field coils? Is that what you had? Okay. Start-stop system includes what components? Question number 3.
C.
All of those, right? Okay. We did that one. Which unit contains a hold-in winding and a pull-in winding?
Is it the B?
Solenoid, yeah, right? Starter can be constructed in a smaller size due to the use of gear reduction and permanent magnets. Overrunning clutch does what?
Protects the starter
Protects
motor.
starter motor from material rapidly. Yeah, we did that, didn't we? Brushes are used to transfer electrical power between what components?
commutator.
See?
Oh,
Hey,
A, yeah. Can we say
yeah.
A? Fuel coils and armature. Armature is what has to rotate. Starter motors operate on the principle that what? What has to happen in order for the starter to work?
G.
This armature has to rotate, yeah, it rotates from the strong magnetic field toward a weaker one. Okay, which starter system component uses a small amount of current to control a large? We did that one already. Solenoid or the relay? All right. Okay, 53 talks about service and diagnosis of the cranking system. So at some point in time, you're going to be professional automotive technicians. That's the goal, right?
Yep.
That's why you're here, right?
Yeah.
Okay. At some point in time, probably more than once, somebody is gonna call you and say, hey, can you help me out? My car won't start. Obviously, you can't fix a car over the phone, right? Although I have a few times. If they can describe it properly, I can at least probably tell them what's wrong with it. So, let's say that happens. What's the first thing you're gonna ask them? What's that? Okay, it's not, it's a good idea,
Is
but
it
what's
turning
the,
over?
what's the
Is it
first
clicking?
question you're gonna ask them? Somebody says, my car won't start, because most people don't know anything about cars, right? All they know is they get in their car, turn the key, push the button, whatever. If it doesn't start, it's got a problem,
Yeah,
right?
so what do you mean?
So
it
what are you
doesn't
gonna
start?
ask them? What's the first thing you're gonna ask them to help them figure out what's going on with it? At least point them in the right direction, or say, you know, I'll come look at it, or, you know, have it towed to the house, whatever.
Is it clicking or does it try to turn over?
Okay, all right. Does the engine crank? Does it turn over? Okay? If it doesn't, what's the next thing you're gonna do? If they say it doesn't crank or just clicks or whatever.
If it's
What's the
cranking.
next thing in the diagnostic process? It doesn't crank, or it just clicks, or it cranks, but it's really slow.
Check the battery.
The battery, yeah, of course. The battery isn't good, it's not gonna crank, right? Okay, so you ask them if it cranks over. If they say no, probably needs a battery, maybe the alternator went bad, killed the battery while they were driving. Depends on if it died while they were driving down the road, or if they parked somewhere and they went out to get in their car and it wouldn't start. If they were driving down the road and it quit, and then it won't start, the alternator went bad, yeah. Okay? That's what keeps the car going while you're driving. Now, if they were just parked somewhere and they went to get in the car from the store, or from home, or whatever, and it won't start, and it won't crank, big chance the battery's bad, okay? So what are you gonna do if they say, yeah, it cranks over, sounds normal, when it cranks over, it just won't start? It'll crank till the cows come home, but it won't start. Then, you've eliminated the battery, the starter, the wiring, the starting circuit, the control circuit, everything. You've eliminated all of that. Now it comes down to it's not getting fuel, or it's not getting spark, or the timing is off for some reason, valve timing. Maybe it broke the timing belt or something, okay? I made up a sheet for, I'll have to find it. If I still have it, I hope I do. For one of the classes, what I did is I made a kind of a diagnostic sheet or checklist for a no-start condition. How to diagnose a no-start condition, okay? In fact, let me go see real quick if I can get that for you.
4th of June, right?
Mm-hmm.
Do we have a test that Wednesday?
I don't think so, cause that's on Tuesday.
Then we come back Wednesday, right?
Yeah, but I don't know if we have a test. I wouldn't imagine so, we already graduated.
Maybe an ASC.
No, if it's an ASC, then yeah, but other than that, I don't know.
Okay, this didn't come out of a book or off the internet or anything, I just made this, okay? Fairly accurate, I think. You get an idea to hang on to that or read it, understand what's going on. You get a car that won't start, if you follow that, you hopefully won't end up chasing your tail. You'll be able to fix it quicker and easier, okay? Extra one for, what's his name here? Okay. Getting better? Cool down a little bit? Okay. Anybody breathing? Might have to go down one step with it.
We can keep these?
What's that?
We can keep these?
Yes, you can. I'm counting on you keeping them, because you're not gonna remember all of that.
No. Not a time.
If you get a car that won't start, that's gonna help you, okay? All right. How to troubleshoot a starting system problem. Pretty good indication of how to do it on that sheet that I made for you. We've talked about voltage drop tests before. The only time you would typically do a voltage drop test is maybe if the battery was good, starter was good, but still had a problem with the cranking, maybe you had a bad connection, okay, and you can check, maybe you had a bad cable or terminal was not making good contact with the battery. Sometimes the battery terminal can look okay, look like it's making contact with the battery, but it's not. Sometimes all you gotta do is just move it a little bit and the car will start. Because just because it looks like the connection's good doesn't mean it is, okay? Voltage drop test is good for determining if you have a problem with high resistance in a circuit. Circuit testing for the starter, amperage test, and determining the necessary action, how to remove a starter motor, that should be pretty obvious. We're not gonna go through the service of the starter motor because, again, you're not gonna pull a starter apart and figure out what's wrong with it and buy parts for it. You're just gonna put a new starter on it. So we're not gonna worry too much about that. Symptoms, components for proper operation, steps involved. Obviously, this is the same as you've seen 100 times before. Always verify that you actually do have a problem. Somebody brings their car and says it won't start and it starts, what are you gonna do? You can't fix something that isn't broken, right? Intermittent problems exist. Maybe your car won't start sometimes it will, sometimes it won't. So at some point in time, you're gonna get a car where somebody complains about something, but you can't duplicate the problem. Doesn't mean the problem isn't there, it just means it's not occurring at that time, okay? Sometimes you'll have to keep a car for a while to get it to act up or drive it or something, to get it to duplicate whatever the customer's concern is, all right? But always verify that the problem exists. Visual inspection of the battery, the connections, test the battery, make sure it's good. Check the control circuit. Control circuit is what causes the starter to actually start to operate. That's the low voltage circuit, right? That's the ignition switch, clutch switch, safety switch, neutral safety switch, whatever happens to be, it's solenoid. If necessary, you can do a voltage drop test of the starter circuit. Also, make sure that the reason it won't start is not because the theft system has failed. Okay, cars have factory anti-theft systems on them. If for some reason that something goes wrong with that system, the car will not start.
Now, depending on the car, it may not do anything when you turn the key. It may crank and not start. It may start and then shut off after 2 seconds or something like that. Depending on the car, they don't all act the same. Make sure that you don't have a problem with the theft deterrent system. And again, you're chasing your tail. Why won't this car start when you should be diagnosing the theft system? All right? And normally, if that's the problem, you'll see a light on that looks like that, right? They'll show kind of a picture of a car with a lock next to it, okay? If that light is on, you've probably got a problem with theft deterrent system. Put a scan tool in it, check the codes. If you do, that's why it won't start. Voltage drop test. It's the drop in voltage that occurs when current is flowing through a resistance. Remember, when you're doing a voltage drop test, you always have to have the system operating, okay? If you're going to do a starter, or if you're going to do a voltage drop test on a battery terminal, one terminal on the post, one terminal on the actual terminal, crank the engine, okay? The system has to be operational in order to do a voltage drop test. The test procedure, you're going to have to disable the engine some way so that it will not start. You want it to crank, not start, okay? You can't do a starting system voltage drop test if as soon as you turn the key, the engine starts. That doesn't do you any good, right? The engine has to just crank. So you have to do something to disable the engine from running. Sometimes it's as simple as pulling a fuse for the ignition system or fuel injection system, something like that. Just make it so it won't start, okay? Connect the voltmeter between the battery and the starter motor, crank the engine, observe the reading while the engine is cranking. Test the voltage drop across the solenoid, voltage drop on the ground side of the circuit, which you'll see done with the meter here in several different slides. Voltmeter hookups for voltage drop testing. You're probably going to see pictures like this on the test, and it's going to ask you what's being done, okay? You're going to have to know, based on where that meter is connected, what is going on in that diagram.
And this is the voltmeter hookup for the voltage drop test.
That's exactly what it is. It's just checking for high resistance in the circuit while the circuit is operational. Older Fords used an external starter solenoid. It was not on the starter, it was actually under the hood on fender well or something like that. It was actually pretty convenient to for testing purposes. As you can see, this is an older system that Ford used. Solenoid was not on the starter. Maximum allowable voltage drop, about 200 millivolts. We can actually go outside and do some of these tests on a car. You guys want to do that?
Yeah.
Obviously, you learn more doing it, right? Okay, what's going on here?
They're testing the terminal and the what's it called?
Voltage drop.
It's a voltage drop test, but what's he actually, where is he trying to determine if there's a problem?
Between the connection and the battery itself.
Right, at this connection right here. One lead is on the actual battery post, the other is actually on the terminal. You crank the engine, look at the meter, it should not exceed 200 millivolts.
So what if it does?
If it does, this connection's bad. So at that point, you would take this off, clean it, put it back on, check it again, probably gonna be okay. If it's not, you may have to cut this cable and put a new end on it or something like that. Maybe there's just too much corrosion or problem with connection to where this cable end would have to be replaced.
A couple weeks ago in the shop, we had a truck come up, and that bottom part, point at it, 'cause
Right here?
Nah. like over up on the actual terminal. This part right here. Like from here.
Okay.
All the way around, but it was still connected to this somehow. And it wasn't connected to the bottom part, so it like cut off a little ring. And that part would not come off. We couldn't get the terminal off to change the battery.
Oh, really?
Yeah, so we ended up having to send it to main shop so they can
Oh,
actually
really?
cut it off. Because I don't know
Yeah.
how the fuck that happened.
Now, some of these, depending on the car, you're not gonna be able to change the cable end. You probably have to change the entire cable.
Oh, wow, really?
Mm-hmm. Depending, sometimes there's not enough extra cable to cut this off and have this, you know, you don't have a couple extra inches of slack in the cable sometimes. Or the way the cable is designed, you're not gonna be able to properly connect a new end to it.
That almost happened. That almost happened to me. Yeah, with the truck, that almost happened when I was trying to get the wire.
Oh, yeah.
Remember? Yeah, and it was almost too short, like it just.
Oh, yeah, on
Yeah.
yours, yeah. Yeah, I saw that.
Yeah.
Okay. What is the answer to this question?
To test the voltage from the battery to the engine.
Checking resistance.
Checking for what?
Resistance.
Yes. Unwanted resistance in the circuit, meaning you don't have a good connection for whatever reason. Okay? Control circuit testing. The control circuit is what? An open or break anywhere in the control circuit prevents starter operation. The control circuit is what gets the power to the solenoid, gets the engine cranking, okay? Light switch or neutral safety switch, crank, some engines have or vehicles have a crank fuse, so you would just look in the fuse panel for that fuse if you had a problem there. Open the ignition switch in the crank position, that happens not very often, but it could. If it's computer controlled, you don't even have to worry about this because there is no problem typically there. Starter relay module if equipped. Make sure the anti-theft controls are not causing you a problem. Starter amperage test, slow or no engine cranking. Battery should be at least 75% charged. These are your specifications for what your starter should draw, depending on whether you have a 4, 6, or 8-cylinder engine. Normal starter draw is somewhere around 150, 200 amps on most vehicles. Amperage draw test, all you have to do is use the amp probe. Those inductive clamps work really well on that particular way to do it. Starter removal, this is again going to be pretty much the same for every vehicle. Disconnect negative battery cable, disconnect the wiring and the bolts, whatever it takes to get to it. So basically that's all that amounts to. This isn't going to be exactly, you know, the same for every car, but basically it will be, okay? Very first step though is always important. That's going to be the same for every car, okay? Disconnect the battery cable. Do whatever you have to do to access the starter, take the bolts and the wiring off of it, and then just pull it off. This one is located under the intake manifold. That was not very much fun to do on that particular engine. Okay. Most starters and motors replaced as an assembly. Some older ones can be serviced, but you're gonna see that. Don't worry about that. You can test all of the pieces in it, but again, you don't have to. This is what the internals of a starter look like on this particular one.
This one does not have a planetary gear set, I don't think. Does not look like it. Home check on the solenoid. Gonna give you your specifications there for your windings. This is there's gonna be a question regarding bench testing a starter on the test tomorrow. Let's see what it says. Bench testing a starter should be done after reassembling an old starter, before installing a new starter, or after removing the old starter. It's going to be before installing a new starter and after repair of an old starter. All right? Bench testing. All that is just making sure the starter works before you put it on. Chances are it does, especially if you just pulled it out of the box and it's new. They're supposed to be tested before they put them in the box and ship them to the store, but you never know. Ensure the starter operates properly before you install it on the car. Make sure the wiring and the connections are all good before you do it. Starters don't use shims anymore. They used to set the clearance between the flywheel and the actual starter drive. Now the way they're made, they make it a whole lot easier for you guys, because no shims anymore. Most of the engine is pretty much good to go at that point in time. They will create a whine if the starter drive and the pinion between the flywheel and the starter is not correct. Starting problems, concerns: starter motor winds, rotates slowly, fails to rotate, produces a grinding noise, or the starter clicks when it's engaged. The starter clicks, probably the battery doesn't have enough power to actually rotate the engine, only has enough power to actually engage the solenoid. Okay? Normally when you hear just a click, the battery is bad. All right? Could be connection or something like that, but I already know that. You already have this one done? Yeah? All right. Anything new on the Camaro?
So they figured out it was a machine shop fault. What happened? And
Didn't say they sent it over to a different place?
Yeah, and they seen the problem and put it in the machine shop that did something wrong. That's why the car took its fine. I forgot what exactly what it was, but, and then, and then they getting him everything new, and then they putting his headers on for free, like because of plus. It should be done by Wednesday. That's what he said.
Oh, man, that's too bad.
But they offered him a rental car though.
Yeah, they need to do something.
Can I see what that is, please?
Can I see what that is, please?
I know him. Stupid ass up here. What are you doing here for? Man, I went to school with him.
Really?
Brought his scat back up here. He's one of those dumb kids that go riding around doing donuts at every fucking intersection.
Oh, is that right?
Yeah. He's a cool dude, but yeah, I went to school with him.
What's he doing here?
I don't know, probably trying to find a better career than Amazon.
Oh, okay.
You've been talking about you don't like Amazon.
Oh, okay.
Amazon paid for it,
They do, but the way they handle shit
They
is
micromanage.
terrible.
They micromanage very badly.
They barely give them a lunch, and if they, take a minute over a lunch or a break, they get
Written up.
They work you like a
written
dog,
up.
huh?
Yeah, they really do. They work you like a sweatshop.
Well,
It's that bad.
That's why they have a high turnover rate.
mm-hmm.
And they have a set amount of sick days you can call off. So let's say you get sick 2 to 3 times, and then the 4th time you get sick and that's not the amount you have, they'll fire you for that.
Even for Amazon drivers.
Amazon drivers have the easy job. We're talking about the warehouse workers.
Anybody still working? No? All right. Let's go do it.
Which one is a armature? B?
B? Yeah. B is the armature, okay.
After installing the starter, the technician should perform which of the following: D.
That's a Medicaid for proper operation. Okay,
Both?
yeah. Mhm. Both of them.
Number 3, a D6 is being tested for a starter amperage draw. The initial surge current was about 210 amperes and about 160 amperes during cranking. Technician A says that the starter is defective and should be replaced because the current flow exceeds 200 amperes. Technician B says that this is normal current draw for a starter motor on a V6 engine. Who is right?
I got the on page 6.
Okay, so what did you get?
B.
You got B? That is the correct answer. Initial surge goes over 200 amps. Nobody cares about that. It will do that when you first crank it, and then it'll level off to what it actually is drawing for cranking.
Oh, question 4. Which of these can cause a starter noise? Is this C, defective starter drive?
Effective starter drive.
Yeah, that's on the page 616.
Okay, if you were paying attention, you know what's going on with that question that you're gonna see tomorrow.
This also shows the upcoming watt. Just indicate reading I put A too high.
Is it inconclusive measurement?
I got A2.
Doesn't it say
Voltage reading is obtained by cranking the engine. What's going on? Where are the cables connected?
negative and ground?
Okay, the actual negative post
Yeah.
and a ground, which means they're checking the cable, right? 0.816 volts, that's basically 816 millivolts. That's way too high.
Yeah.
Shouldn't be over 200, right? All right.
Okay.
A voltage drop test on the starter control circuit is used to test which of the starter components. A,
That is correct. Wiring and the connections.
What is the first step to follow when removing the starter? Disconnect the battery from negative cable.
That is correct.
If the starter winds when engaged, which of these is a possible cause of defective solenoid?
I think the solenoid will
I got
make it
A.
whine.
I just thought of the last step.
Okay. Wired and defective starter drive for wine. Okay, that's actually a mechanical noise, not an electrical noise, which would be all of these. Okay? All right.
Number 9, what component or circuit can keep the engine from cranking? All of the above.
Okay?
Test?
Okay? All right.
Okay, the vehicle does not spark enough to start. Technician A says that the battery will be discharged or defective. Technician B says that the negative cable will be used at the battery loose drive. Is it both?
The engine doesn't crank fast enough to start. Battery could be discharged defective, of course it could. Cable could be loose at the battery. This could be either cable. but yes, both of them. Okay? All right, 63B. We did this one already, it's both of them, okay? We did this one already, it's B. Which component can keep the engine from cranking? We did this already too, any of those. And this is another one of these.
Ron, how many questions are in the test? Is it 40 again?
I think it's 40, let me look. Which is 36, actually, so. All right, this one also, might want to make a note of. Cranking system, voltage drop test is being done. Higher the voltage drop, the lower resistance in the circuit. Like B says, the higher high voltage drop in the cranking circuit wiring can cause the engine to crank slow. Who's got the answer to this question?
Is it B?
Is it B? Let's see. Technician A says the higher the voltage drop, the lower the resistance in the circuit. Mm-mm. The higher the voltage drop, the higher the resistance in the circuit. That's what you're testing for. High voltage drop in the wiring can cause the engine to crank slow. Of course it could. Did you have a question, Terrence?
No. That's something.
All right. We did this one already. Grinding noise, start or drive, all right? If I'm not mistaken, this one you might also see again. The cranking circuit should be tested for proper amperage draw, yes or no?
Yes.
That's a yes, right? Technician B says an open in the control circuit will not prevent starter motor operation.
Yes, it will.
Oh, yes, it will. If you have an open in the control circuit, that starter is not going to do anything. Okay? A only. All these can cause a starter not to rotate except for one of them.
C's crankshaft. No.
Or not to rotate except.
Field coils.
What do you think about that one?
Crankshaft. Except.
If the engine was seized, would the starter rotate? No, because as soon as engaged with the flywheel, it would just stop, right? So that one would do it. Armature, that would do it. Shorted field coil, that would do it. Starter drive will not cause it not to rotate. Okay? Number 9. I don't agree with this, and I'll tell you why in a minute. What do you think the answer is?
The condition of the engine oil.
Right. It says that would not be a step in diagnosing a no crank.
Yes, it would.
You would check
What?
that though.
What if the customer
Has sludgy-
didn't change their oil? What if it was low on oil, so low that the engine actually locked up? That would cause a no crank, wouldn't it?
Yeah.
Wouldn't be one of the first things you'd do, but it's easy to do, and you would always check condition of the engine oil. I've actually seen that happen many times. Car comes in, won't crank, engine's seized.
So if we come across a question like that, on the test, what would we select when it all makes sense? Or when there isn't one that you would not do?
There isn't one that you would not do, however, they're basically getting at your testing things for electrical.
Okay,
This kind of doesn't fit, but you would still do it.
okay, okay, so
Okay.
just pick the one
Yeah.
that doesn't fit.
Yeah.
Okay,
It's not that you wouldn't do this, it just doesn't fit the rest of them. This is all electrical checks.
oh, you said that before, you did say that.
Okay, we did that last question. All right, let's take a quick break and we'll get back to the next chapter. No, I don't know, whatever. 10, 15, I guess.